Hello everyone. So in today's experiment, we are going to discuss about the emissivity. Okay. So in our emissivity measurement apparatus, the basic funda that we are going to use is that if for any body, suppose you say there's a body, this is a body, and uh, there is some incident radiation which is falling on it. So we have seen in our lower standards that what happens is it basically gets into three segments. One is that it might reflect back, and second part is it will absorb it, and third part it will transmit it. Okay, there are these three possibilities, and in real practical cases, all these three happens with certain variations. Some bodies transmit lot compared to the reflection and absorption part. Some body reflect more rather than absorption and transmission. Okay. Now suppose there is a black body. Okay. This is a black body. What will happen if again an incident, the same incident radiation falls on it? So what will eventually happen is it will absorb all its radiation. It will absorb all its radiation inside. Okay, and hence the reflectivity and transmittivity will be equal to zero. Okay. Now, what is emissivity? So in order to come over the definition, we will first have to see what is thermal radiation. So it is basically all substance at all temperature emit thermal radiation. Okay. So for example, our body is continuously emitting thermal radiation. Whatever the laptop screen or mobile or any cloth, everything is basically, it emits thermal radiation. Now, this thermal radiation is basically it's in the form of an electromagnetic wave, and it does not require any material or medium for its propagation. Now, all bodies can emit radiation and have all capacity to also have the capacity to absorb all or a part of radiation coming from the surrounding towards it. Okay, and as I mentioned that an idealized black body or black surface is one which absorbs all the incident radiation with reflectivity and transmittivity equal to zero. Okay, so the next term that we are going to see is called as the emissive power. Okay, what is emissive power? So emissive power is nothing but this radiant energy per unit time per unit area. Okay, this is the definition of emissive power. And what is emissivity then? The emissivity is nothing but the emissive power of any surface upon the emissive power of black body. Okay, so we usually denote it by letter E, which is emissivity. So the emissive power of any body is denoted by small e, and emissive power of a black body is denoted by small eb. Okay, and for a black body, the absorptivity is 1, right? Hence, by the knowledge of Kirchhoff's law of emissivity, the black body becomes unity. Okay, the emissivity of black body becomes unity. Now, let us look into the our experiment part. So this is our experiment setup, where the aim of this experiment setup is that we need to find the emissivity of a body. Okay, of a body. So over here in the setup, you can see that there are two plates, right? So this plate is the black plate, okay, or we can call it as the black body, and this is a test plate. Okay, it can be of any material. All right, so we call it as test plate. We don't know what is the emissivity of this body, but we know that the emissivity of black body is equals to 1. Okay, so we are going to find out the emissivity of this body corresponding with the emissivity of black body. And in the experiment you can see these three wires. Okay, so these three wires, I mean the yellow color wires, the yellow color wires are nothing but the thermocouples. Okay, so over here you can see that one is one of I'm sorry. So one of them is it is attached to the black body. One of them is attached to the test plate, and one thermocouple is basically it is just uh, it's absorbing. I mean, it is kept in the open air. Okay, and this entire setup, this whole setup, is kept inside an enclosure. Okay, you can see an enclosure which is blocked with the help of glass or any surface which is having less thermal conductivity and other properties. Okay, so this is the test area. Okay, the entire section, and we are going to determine the emissivity of these of this test plate. Now on the other side you can see that there are certain settings, or there are certain knobs that for operation of this experiment. So this one over here is nothing but the this one is nothing but the on off switch. All right, now over here you can see you know a switch which can be switched between test plate and black body. Okay, so I'll explain what it does. Over here you can see that it is written test plate, and there is a uh, you know there is a dimmerstat, and on this side actually it is a black body or black plate and again a dimmerstat, and there is a voltmeter, there is an ammeter and a temperature indicator. Okay, so what happens is, if suppose I want to set a certain voltage of test plate, so what I will do is I will turn this switch towards the test plate, and I can change the voltage accordingly, and correspondingly the voltage of the test plate will be shown and current will be shown. And suppose if I want to change the input to the black body, I will switch this knob or switch it towards the black body, and then I will use this knob in order to change my voltage. Okay, so correspondingly the voltage will be shown in the same reading, same digital meter and the ammeter. Okay, now this temperature is basically used to determine the temperature of these three thermocouples. So suppose black body, for the black body, we will call the temperature as T1. Okay, and for the test plate, we'll call it as T2, and the third is T3. Okay, so there are three thermocouples which would be indicating its temperature in over here. Okay, now for before when we start this experiment, what we need to know is that since the black body, it absorbs all the radiations. Okay, so basically it will require little higher input or little higher work than the test plate. Okay, so when we are going to set up a voltage, suppose we are going to set up voltage around for a black body, we are going to set it around 52 volts, for example. Okay, then for the test plate, we will be giving only a little less than 52, probably around 49 or 50. Okay, the reason being that the black body absorbs more work. Okay, it takes more work in order to attain the same temperature, whereas the test plate will not absorb much of the energy. So hence a little less voltage is set up. So I have given an just for an example. Okay, so for the first reading, suppose I'm taking 52 for black body, then I might take around 49, 50 or 48 for the test plate. So that the okay. Now after this, after this setup, I mean the first reading. Suppose the you have done this. You started with this experiment. Okay, so this is our observation table. Suppose we will set up for the black plate as 52, for example. Current would be around something 0.2726. Correspondingly, some temperature you will get, and over here I will set it as 59, and some yeah, current you will receive for test plate, and some temperature you will get it from thermocouple 2, and the ambient one temperature you will get from thermocouple 3. Okay, and for second reading, what we are going to do, we will put a little increase the voltage. Suppose I will take 62, and similarly over here I might take 60 or 59 or something. Okay, and what we'll do is, you can calculate what is W1, W2. W1 is nothing but the work done for the black plate, which I can find by using simple formula. W1 equals to V1 into I1. Okay, and similarly I can also find W2, which is V2 into I2. Okay, so I can get this readings, the W1, W2, where W1 is nothing but the heat input to the black body, and W2 is the input to the test plate. Okay, we know the area of the plates can be found out by using this formula pi by 4 d square, right? Where the d, the diameter of the plate is constant, and it is around 155 mm. Okay. Now, as we know, T1 is the temperature of black body, and T2 is the temperature of test plate. T3 is the ambient temperature. EB is emissivity of the black body, and E is the emissivity of the test plate. Sorry, E is the emissivity of test plate. Okay, and there is a constant that we use in case of radiation, which is called as the famous Stephen Boltzmann constant. Okay, which is equal to 5.67 into 10 raised to minus 8. Okay, unit is watt per meter square Kelvin raised to 4. So these are the terms that are required to be described, and by Stephen Boltzmann law, we get that W1 is equals to sigma A E of black body, since it is 1, and T1 raised to 4 minus T3 raised to 4. Okay, this is the formula where sigma is Stephen Boltzmann constant, A is the area, EB is the emissivity of the black body, T1 is the temperature of the black plate, T3 is the temperature of the ambient plate. Okay, and similarly W2, that is for the test plate, equals to sigma AE T2 raised to 4 minus T3 raised to 4, right? Okay, and suppose if you subtract this two equations, if you subtract equation number 2 from equation number 1, you will get an equation which is W1 minus W2 will be equal to these two terms, this term, and sorry, these two, sigma A and sigma A is going to be constant, you don't need to find, and the remaining would be EB minus E into T1 raised to 4 minus T2 raised to 4. Okay. Now from this relation, we are aware with the we can find out W1 with V into I1, W2 similarly V2 into I2. EB is the emissivity of the black body, which is equals to 1, and we can find E. T1 is the temperature of the black body surface, T2 is the temperature of the uh, test plate, and so from this experiment we can find the value of E.